Learning targets. I can recall information about parabolas and quadratics, like how it opens, up or down, the vertex, the axis of symmetry, and the x-intercepts. And also, I can effectively use the vertex form of a quadratic equation. We will learn that today as well. All right? So, what do I remember about quadratics and parabolas? Okay? We have the ax squared plus bx plus c form right here. Okay, that's what we have. We're used to seeing that. How can I tell if that parabola opens up or down? If it's positive or negative, what specifically? The first thing, my A, right? If A is positive, it's a smiley face. If A is negative, it's the frowny face. And if you want to get fancy in math terms, we can just say if A is greater than 0, then it opens up. Okay? Then it opens up. If A is less than 0, then it opens down. Okay? However you want to write it, there you go. But we always look at that first term, which is the A.
Vertex is C, y-intercept
Let's go. Let's figure it out. Let's see. X of symmetry. There is actually an equation. This is always x equals. It's always x equals. Our parabolas will always open up or down in this class, okay? We aren't going to have any sideways parabolas. So it's always going to be x equals. But how do I figure out what the axis of symmetry is just by looking at the equation? It is negative b over 2a. So you negate whatever your b value is and divide it by 2 times your a value. And algebra 1. Well, integrated algebra, I don't know, algebra 1 or 2. Yeah. So that's a simple equation you come up with. All right? Done. What about the vertex? The vertex isn't a line like the axis of symmetry. It's a point. By the way, the axis of symmetry, what is that? What is, when I come up with that x equals whatever value that is, what is the axis of symmetry?
It's a line that's placed the parabola into 2 equal lines.
Perfect. Yeah, it's a line that goes, it actually goes right through the vertex. And it's that symmetry, right? It's the mirror. It's where the parabola is mirrored over. All right? Cuts it in half. So, if the axis of symmetry runs through the vertex, and the vertex is a point, that's what's going to be x and y. And guess what? We have our x. This value right here, that is actually going to be the x value of our vertex. Which leaves us, how do we figure out what the y is? Well, if we have this value here, why don't I just plug it in here and here and solve for y? So
you just put solve for y?
I just put, plug x into equation and solve for y. To equation and solve, solve for y. It's that simple. And now you have your x and your y. Last, the x-intercepts. Does anyone know how to get those by the equation? Well, what's another term for x-intercepts? It's also the roots, which is also the solution, which is also the zeros, right? So if I define the roots or the solutions or zeros to an equation, yeah, I set the equation equal to 0 and solve. But if it's a quadratic, how do I solve it? I factor and solve. Right? With his cheeks and T-bone. Right? Cheeks and T-bone. Alright, sometimes you can't factor it. If I can't factor it, so first of all, I can't find two numbers that multiply to be the last number and add to the middle. Then I can try slip and slide, right? If I can't do slip and slide, then I got to do the quadratic formula. Negative b over 2a. So I'd say factor and solve. So I could do this and then this, T-bone, right? This will be first, If you can't just do that right off the bat, then second I would do slip and slide. Slip and slide is what S stand for. Then if I couldn't do that, then I would go right to the quadratic formula. Yes, it is. If we want to write it down, let's write it down. Quadratic formula. Yeah, negative b plus or minus the square root of b squared minus 4
AC over 2A.
AC. And it's all over 2A. It's not just the radical, it's over 2A. It's all over 2A. You'll need to write that down. All right, so using algebra, let's describe the following graph. All right, well, first, how does this open? How does this open?
Up.
It opens up. And how do we know that?
Because the A is positive.
Yeah, because my A value, which is 3, is greater than 0. Okay? So we know it opens up. That's the first thing we know. Now, yeah, let's figure out the axis of symmetry. We said it was x equals what?
X equals negative B over 2A.
Negative b over 2a. Now, our a is 3, our b is 12, and our c is 11. All right?
Negative 12 over 2 times 2.
Yeah. We negate our b value, 12, over 2 times our a value, which is 3. And that is negative 12 over 6.
And negative 2.
Negative 2. So x equals negative 2. That's our axis of symmetry, right there. Now, if I were to graph an x equals, isn't that a vertical line?
Yeah.
And it crosses the x-axis right at negative 2. All right, so we know it opens up, and the axis of symmetry is going to be right at x is negative 2. Not bad. What about our vertex? Well, our vertex, you got it, is a coordinate, right? We need an x and a y, don't we? Well, we have an x right here. So I have negative 2. I just got to figure out what the y is. And I do that by plugging negative 2 into our equation.
Negative 2 squared plus squared.
Yes. Thank you for saying parentheses. Because when we input this, I say y equals 3. Put the negative 2 in parentheses. Do not put the exponent in the parentheses with it.
So you only squared negative 2, right?
Right.
So you would get a positive 4 times 3.
You got it. Plus,
That's 12.
12 times negative 2
You get 24.
plus 11. So you're saying you get 12 minus 24 plus 11.
You get negative 1.
That's negative 1. And that's your y value. If you do not put that negative 2 in parentheses when you square it, the calculator will square the 2 first, and you do 4, then apply the negative after, and you do a negative 4. If you put the parentheses, the negative in the parentheses and have the exponent out, the exponent will square the negative with the 2. So I'll do a negative 2 times the negative 2 and give you a positive 4. All right? So, we now have the vertex right here. So we know the vertex is negative 2, comma negative 1. We know the axis of symmetry goes right through that x value, negative 2. And we know it opens up. Okay? Now the last thing that we need to figure out are the x-intercepts.
The roots.
The roots, the zeros, the solutions. That means I take my equation and set it equal to 0 and solve, right? 3x squared plus 12x plus 11. Okay, first of all, that is not a 1x squared. I can't just use the factor sum method. I can't say two numbers that multiply to be 12 that add to be 11. Or excuse me, vice versa. Two numbers that multiply to be 11 that add to 12. Because 11 times 1 is 11. 11 plus 1 is 12, but we have the 3 here, so we can't do that. So if we were to try slip and slide, and don't write this yet, I will tell you when to write this. If I were to try slip and slide, right?
33.
Yeah, this would go away. X squared plus 12x plus 33. Are there two numbers that multiply to be 33 that add to be 12?
No.
No, which means you cannot do slip and slide. If you cannot factor that, slip and slide is off the table.
So you need to do the quadratic equation.
You got it. You got it. So I'm going to just rewrite that right here. We said it's negative b plus or minus
radical b squared minus 4ac all over 2a.
2a. You guys got it. A is 3, b is 12, and c is 11. So let's plug and play, people. We negate whatever b is. Right, and whatever I can put a number, I put in parentheses. Okay? Plus or minus the square root of our b value, which is 12, squared minus 4 times a, which is 3, times c, which is 11. Okay? All over. Not just the radicals over, but all over 2 times a, which is 3. And we'll clean this up. We'll definitely clean this up. Right? So I'm going to negate my 12. I can drop those parentheses. Plus or minus the square root. Now, someone do me a favor. Without the radical, just this stuff right here, if you put that in your calculator, what do you get? Yeah, you're going to get 144, then 12 squared, minus 132. Isn't it? It's 12 times 11, isn't it 132?
No, it's negative 121.
That's 11 times 11.
Almost.
It's 11 squared. No, not good. You were off by 1. You're off by 1. So if I subtract those, I get 12. So that equals 12 under the radical. So that's what I'm just going to put under the radical here, 12. All over 2 times 3 is 6. Is there any other simplification I can do here? I can. Can I what?
You can divide.
Not yet. If I divide the 6 into 12, it has to divide by the number in front of the radical as well. It has to go into all 3. Right now, this is a 1 right here. When it's not written, it's a 1, right? And if 1 goes into all of them, well, they stay the same. But I can simplify that radical 12. I can simplify that radical 12. Yeah. Radical 12 is what? That is radical 4
and 3
times radical 3. And what is the square root of 4? 2. So radical 12 is the same thing as 2 radical 3. So I'm going to put this in place of my radical 12 up here. So I'm going to say I have negative 12 plus or minus 2 radical 3 all over 6. Now I have 3 numbers outside the radical. I have my negative 12, my 2, and my 6. What's the common factor between them all? 2. 2 goes into itself once. 2 goes into 12 6 times. 2 goes into 6 3 times. So when I rewrite that, I have negative 6 plus or minus the square root of 3. I can write my 1 in front of there, but I don't have to. All over 3. Those are my 2 roots. Those are my 2 x-intercepts. One is negative 6 plus radical 3 over 3. And another one is negative 6 minus radical 3 over 3. Right? So if we really wanted to take a look at what this looked like, so these are, when they say describe it, well, it opens up. The axis of symmetry is at x minus 2. The vertex is negative 2, negative 1. And it crosses the x-axis at these 2 points right here. Negative 6 plus or minus radical 3 over 3. So, just for poops and giggles, if I want to actually graph this, where's our vertex?
Vertex is negative 2, negative 1.
Negative 2, negative 1. So I go negative 1, negative 2, negative 1. It's right here. That's a vertex, negative 2, negative 1. The axis of symmetry is x is negative 2. It goes right through that, doesn't it?
Yeah.
This is x equals negative 2. This is our axis of symmetry. And it opens up or down? It opens up, and it crosses the x-axis at these 2 points. Okay, now the square root of 3 is like what, 1.6? I don't know. So if I subtract or add a little bit more than 1 to negative 6, and divide it by negative 3, well, that's going to be a little bit more than negative 2, and a little bit less than negative 2. Somewhere around there. I'm just guessing without doing a calculator. So it will open up cross kind of like this, maybe. I don't know. That might not be exact. That's just a rough estimate. I'd have to actually put this in the calculator and figure out where exactly it crosses the x-axis. So, that's it.